In the last video, we talked about the difference between an error and an exception. And we said that errors are always bad, and exceptions, they can be okay. They don't have to strictly be bad. Okay? We also talked about the difference between an unchecked, or we didn't talk about, we mentioned that there are two types of exceptions. You have unchecked and you have checked exceptions. Okay? So let's talk about a few of the unchecked exceptions that we have no doubt seen in our Java time so far. Okay? One of the first is probably, let's say, index out of bounds exception. Index out of bounds exception. Okay? Now, what's interesting is that, remember how we said a long time ago that everything in Java is an object. Okay? This is also true for exceptions, and we can represent exceptions as objects and have hierarchies to them. Okay, so what do I mean? Well, index out of bounds is pretty general because you can go out of bounds in different things. For example, you can go out of bounds with an array. So you may have seen the array index out of bounds exception. I'm just going to abbreviate it. And you may have also seen the string index out of bounds exception. Okay? Both of these inherit from the index out of bounds exception superclass. Okay? But they represent a different kind of index out of bounds exception. Okay? So you encounter this one when you're using a more general data structure, such as like an array list. But with an array, of course, you get this when you're using an array index, or when you're using an array. Okay? You'll also get this if you use like a linked list or something, something to that effect. But it can also be used to, it can be used in cases of indexable data structures that are not necessarily backed by an array. String index out of bounds exception is very straightforward. It's usually when you try to index beyond beyond the length of the string or into a negative index. Okay? So that's array index out of bounds exception. But what about some other ones? What are some other ones? Well, we also have, let's say, arithmetic exception. And this one we've probably seen if you try to do something like a division by 0. That's not good. You can't divide by 0. Okay? There's also, let's say, null pointer exception. And this occurs when you try to, let's say, you'll like declare an object, let's say a string, we'll set it equal to null. And then later down the line, you try to invoke a method on that null object. Okay? This normally happens, this doesn't usually happen when you directly initialize something to be null. It's more often the case that this occurs when you have an object that has, or a class that stores an object as an instance variable or even a static variable, and then you don't instantiate it anywhere else, and then you try to use it somewhere else. That's usually that's the more common place that you will encounter one. Or if you have like an array of objects and you don't populate a particular index, that can also be a place. Okay. Let's see. There's also class cast exception, and this occurs when you try to, for example, treat one object as if it were another object, but there's no discernible relationship between them. So what do I mean by that? I mean that, for example, if you try to, let's say you have an integer wrapper class variable, and you're going to try and cast, let's say, a string to that integer class type. This will not work because we know that there's the object superclass that everything inherits from, and then you have integer, and then you have string. But there's no discernible relationship between these two. Integer does not extend string, string does not extend integer, and so it's not possible for you to cast between them. Okay, so you get a class cast exception when you try to do this non-discernible casting idea. Okay. Let's see. There's also the no such element exception, which certain data structures can throw if you try to, let's say, like if you call, I think, get first or get last on a list, if there is no first or if there's no last, it will throw a no such element exception. No such element exception. Along those lines, there's also the empty stack exception. So now we're getting into like a more specific type of exception. Okay, so if you try to peek or pop on an empty stack, then this is the exception that will be thrown. Okay, so those are a few types of unchecked exceptions. But why are they called unchecked exceptions? The reason why they're called unchecked exceptions is because you do not have to catch them. And by catch, I mean you as the programmer do not have to write specific code that will watch out for these types of exceptions that can be thrown. Okay? And by thrown, I just mean that you can encounter them. Okay? So you don't have to write any code that guards for those types of exceptions. But compare that with what's called a checked exception, which means that the compiler will enforce that you write some code that accounts for that type of exception. There's no getting around it. You have to write some kind of code that will guard for that type of exception. And we'll talk about checked exceptions in the video after the next one.